So, hello everyone. A very good afternoon to all, dear authors and invited guests. Welcome to Technical Session 5B. Myself, Anisha, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the 9th International Conference on Information and Communication Technology for Sustainable Development, ICT4SD 2024, Goa, India. The ninth edition of the conference is being organized in a hybrid mode. The physical event is organized today in Goa, and the virtual event is being held through Zoom today and tomorrow, that is 8th and 9th of August 2024. I hope you all will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 10 presentations. Each presenter will be given 8 minutes for the presentation and 2 minutes for question and answers. And on 7 minutes, I will raise a gentle reminder. There's another request to all the participants that you all please stay connected with us till the closing of the session. And if you have any update or query, then you can write it to me in the chat box. So just before we start the session, I would like to introduce you all to the chair for this session, Dr. Priyanka Verma, an experienced educator and trainer in the area of lecturing and technology with a track record of working in the higher education industry. Skilled in computer networking, Microsoft Excel, communication skills and leadership skills, creative thinking, teamwork, critical analysis, and problem solving. Currently, she is working as the assistant professor since May 2015 to till date, also doing part-time research on data science. So I welcome you to the session, ma'am. Would you like to give an opening remarks to all the participants?
Mm, Just wish you all the very best to all the participants. Let's see what you all have.
Okay, thank you so much, ma'am. So let's just start with the session now. And first up, we have Vishal Singh P. Gohil with the paper title Abnormal Event Detection in Surveillance Videos Using an Enhanced Fusion Method. Sir, are you there?
Yes, ma'am. Is it audible?
Yes, sir,
Hello?
you're audible. Yes, sir. You can share your screen
Sure,
and
ma'am.
start the
Yes, I'm there.
presentation. Sure.
All right. Good to do that. It's very good morning, everyone. I'm so glad and very much honored to be a part of this international event. And thanks again for an opportunity to share some of my thoughts and some of my research work. So basically, the topic I'm about to talk is some sort of abnormal event detection using surveillance live. See, right now we are focused on the footage, and from the footage, I'm supposed to detect some sort of abnormal events. We have already a model which has been trained, and those trained model will be finding some sort of event happening. And based upon those event happening in future, prospective would be like to make an alarm or to go for the some sort of notification authorities. So basically, that was an idea behind that. Okay. So the primary objective is, let me tell you, that it all started with multiple segment learning, MSL, ranking loss algorithm. So basically, it is primarily focused on um, rank loss of the blurring and all. And based upon that, in the second, we have focused on the object detection so that out of the random kept on changing backgrounds and all, a particular object, a particular event will be detected. So basically, my ideology it was to first of all capture and get the footage from the video and put them into the segmentations. Those segments will be further optimized into different boxes. After those boxes will go for the object detections and post estimation so that we can find some sort of accuracy regarding the events. If certain events are happening, uh, Basically, it is a fusion of some of the technologies of basically some of the well-known and fully functioning algorithms. One of them is YOLO, one of them is TCNN, and using those algorithms, I have somehow proposed this model that as a fusion model, it should be working and giving us the better accuracy. Okay, so here we have model integration and fusion. So we have different containers depending upon the accuracy of event happening, and this is uh, how we are going to do that. We are going to do that. First of all, we'll be capturing the video using some sort of CCTV surveillance cameras, or live footage could be later on replaced after the enhanced accuracy once it has reached up to a certain mark. Later, once we have the full footage available to us, we are going to cut those videos into different small segment videos so that it's going to be efficiently processed. Once we have these videos, then one to one, image to image, every frame will be optimized and analyzed for the event happening. Then every frame is going to be optimized, or you can say every frame is going to be checked for a particular event. Now, depend upon the accuracy check, we have different containers. Those containers will be containing the matching images depending upon uh, the already pre-trained model. And based upon that, we have already YOLO library with us. We have library with us. And apart from that, YOLO 5 is there, RCNN is there. Using those things, we have object detection so that we should be in a position for the better object detection. Apart from that, we have to, you have to use a little advanced hardwares also. For example, Tensor RT that is offered by NVIDIA, because we are here to image here for the image processing, and we are supposed to do it at the faster rates. So a large bulk of image can be processed at a time. Okay, real-time object detections, and for that, uh, RCNN that will be implemented. Okay, once we have detected the pose, we are going to extract the features. For example, right now we have focused on a few specific objects, and we have already uh, 70 images. After training these models with those predefined images, it is going to identify a specific objects. Right now, this model is focused on two particular objects. One of them is a gun, one of them is a knife, and anomaly. Depending upon the scores of the anomalies, we are going to finally detect a particular features, and based upon the features, we are going to do that. So basically, our challenges for like okay, real world, when we are dealing with the live footage, there is going to be multi-view integrations, adaptability. This kind of live issues will be there because they will be posing different results every time. Again, we are going to face with the data augmentation. So we have to train our data with the maximum accuracy. Real-time processing, that's a huge challenge because real-time processing, it's going to be at the same time, we are supposed to deal with a huge footage, and again, we are supposed to give accurate results. So we have to use best of the best of graphic cards or whatever the data processing images. Right now, we are using Google Colab. We are trying to just implement our logics, our things over there. Of course, human factors could be there because angles will be different, the blur will be different, the sharpness and the readiness of the image, that's going to be different. So depending upon that, we have different performance matrices. So these matrices will be comparing whether these results are going to be. So basically, these are the challenges we have to go through in order to propose something that can detect a particular object. So one of them is the complexity of the real world environments. Like we already mentioned that there are going to be so many different scenarios and environments and definitely different things. So variability in anomaly types again. So that's going to be the depending upon the object. So objects can be found in a different shapes and size. And again, the angles will be a big factor. So depending upon that, scalability and efficiency will be different. So again, we have to come to the threshold that up to which threshold these things are viable and suitable for us. Later to that, dynamic change in the environment. For summer, things will be different. For winter, it's going to be different. For rainy seasons, things will be different. Every time there's a difference in the environment or scenario, things should be changed and our model to work on those different things also. So basically, these are the different models and structures that we had been through. And every reference and every research work has their own advantages and their limitations. So basically, what my proposal is the fusion of some of the perfectly efficient research work and all. Some of them are traditional methods, some of them are deep learning, some of them are low-ranking algorithms, and some of them hypergraph construct algorithms. This is basically the proposed methodology, or you can say the steps we are going to go through. The MSL ranking works, that's where we are going to start with all the things. Okay, right next to that, object detection and pose estimation. That's going to happen with your library, and we have to focus on the body poses. Or you can say if a certainty of an image is going to be there or not. GCN is again a big addition to the algorithm. Of course, the processing power is going to be standardized. Different resources are required at the maximum. But again, without this clearly, the things will be like challenging to us. So we have to make an fusion of all each and everything. YOLO is there, if you see an is there, RCNN is there. So basically we have the fusion method which can actually propose event detection with some better accuracy and efficiency. Of course, we are also considering the resource consumption and resource hungry for the graphic cards and other resources. So basically, this is the something. Okay, this is going to be the architecture that we have before we started the programming and configuring of the hyperparameters and all. So actually, we have first of all, that's going to be the capturing of the video. Once we have the full footage, where we can say recorded, the pre-recorded feature, that video at a live, then different partitions, then different containers based upon the image extraction. This image extraction will be compared to the trained models, and right after that comparison, we are going to detect different poses. So once we have this specific poses as for the accuracy and efficiency, we are going to focus on the extract features, and if some certain features which we have specified, if they are happening, some specific notifications are going to take place. Okay. Finally, we are supposed to use the anomaly scores. If it is beyond the threshold, we are not going to be further about it. And if it is going to cross the threshold, of course, we have to take an action. So that's going to be the different steps for us. And from my side,
There's a network problem for this side. Okay, so for now we can move forward to the next one.
Hello. Hello.
Yes.
Ma'am, sorry for interrupting, but can you take my first? My reference ID is 186, but I have my college interviews at 1 to 2 p.m. So I kindly request you, can you take my first?
Okay, if the session share allows you to present first, then we can take it. Ma'am, should we take her first?
Yeah, Anisha, you can go ahead.
Okay.
Thank you so much.
Just give me a second. Yeah, so now we have Shreya Patil with the paper title Enhancing Railway Platform Safety
Yes.
Through Rotating and Sliding Gates with FRID Sensor Technology. Ma'am, you can start your presentation.
Hello.
Yes, the screen is visible.
Okay. Thank you. So good afternoon, everyone. I'm Shreya Patil. Hello. Good morning, everyone. I'm Shreya Patil, and today I will presenting our project title, that is enhancing railway platform safety through rotating and sliding gate with RFID sensor technology. This research was conducted in collaboration with Ms. Shruti Khosge, Professor Dr. Sachin Patil sir, and Professor Mr. Praveen Desai, sir. This is the content that I will cover in this presentation. So, India's railway network is one of the largest network in the world, covering over 10 trillion kilometers annually and more than 5 billion passengers. But there are many accidents that happen due to the gap between the railway and the platform, and the accidents of crossing the track. So our project aim is to enhance platform safety through advanced technology and infrastructure improvement. So it definitely improves the passenger safety. So to provide the context for our project, let's see some videos that of safety issues that faced by the passengers. This is a dangerous situation that frequently occur in India. There are in this video there are elderly woman trying to catch a moving train, and her leg stuck in between the gap between the train and the platform, and she was dangerously injured. There are many more accidents that happen like this. Let's see another video. In this video, there is a dramatic rescue of that 6-year-old boy. That 6-year-old boy accidentally fall on the railway track, but railway worker Mayur Sheikhe saved him from ongoing train. And there are many more accidents that happen like this. And these indicators there are need of to implement more accurately safety protocols. And often these many people are many people cross the track when train is not there, and just for using a bridge to go from one platform to another platform, they cross the track to just save some time. And this risky behavior become dangerous if unexpectedly a train comes. So there is a need to overcome this type of accidents. So this is the statistical review of railway accidents. In this review also we see there are many more accidents are frequently occur due to the gap between the train and the platform and the track crossing. And this review also indicate there is a need to enhance our safety system. So this is our methodology. We analyze such type of problems, and then we studied about the railway platform accidents. Then we visited nearby railway station, that is Takari railway station and the Shenoli railway station. We discussed with railway station master, with workers about this type of problems, this type of accidents. Then we finalized our project design, then make prototype, then took suggestions and improvement, and made final our product. These are some visited photos at the time of we made up our prototype. So as we see earlier seen, there are mostly accidents that happen due to the gap between the train and the platform and the line crossing. So our proposed solution is the safety grill that is a rotating gate to cover the gap between the railway and the train platform and the train, and sliding gate to avoid the people to crossing the track. So this will definitely improve the passenger safety. This is the block diagram. In this block diagram, they illustrate how RFID, servo motor, DC motor, buzzer, that safety grill, sliding gate, and buzzer, how they work together. So firstly, there is a two RFID scanner. That first RFID scanner is stuck on that first engine of the train, and this second RFID scanner is fixed on the last coach of the train. So, and this is the RFID reader that fixed on the platform. So when train arrives, that RFID reader scan that that RFID scanner. RFID reader scan that RFID scanner, then send signal to the microcontroller. Then microcontroller input that signal to then microcontroller send that signal to the servo motor. So servo motor grills turn horizontally or vertically according to train arrive or depart. Then my again that signal sent to the DC motor and buzzer. DC motor are for the sliding gate, slide up and slide down, and buzzer for alerting people on alerting passenger on the platform. So this is our detailed process of our project, how our safety system work. So that's why I want to show some video of our prototype. This is our prototype. Our safety system start in ideal state. So they are waiting to reach the train to the platform. When train arrives, first this is the rotating gate, that is sliding gate. This is rotating gate and this is the sliding gate, and this is manually handed to doors, and the that scanner is fixed on that first engine and the last coach of the train. Then when train arrives, let's see how it works. When train arrives, then our rotating gate moves horizontally and our sliding gate slide down. At the time of implementation, the white color of that sliding gates are totally moved on the ground. So people can easily get in the train without falling on the gap between the train and the platform. And people, so when train departs, let's see how it works. When train departs, again that signal sent to the microcontroller, and again that vertical both gates, that safety gate and sliding gate, that both move vertically, so people avoid to crossing the track. And if by chance any person stuck between that two gates like this, so there are two manually doors, so that can people get out from that manually handled door. So in this block diagram, same explain the working of our system. That is, train reach to the platform, then that sends the signal that train comes in platform. Then sends signal to the Arduino, and then Arduino sends signal to the DC motor and the servo motor. Then that servo motors move horizontally. That moves our sliding gate horizontally, and DC motors slide down our sliding gate. Then when train departs, then again that last coach of the train scanned by the RFID reader. Then RFID reader again send that signal to the RFID to the Arduino. Then Arduino send again that signal to the DC motor and the servo motor. So again that two gates move horizontally, so people can avoid to cross the track. This is our total prototype. So our proposed solution is installing safety grills and installing sliding gate. There are as I earlier mentioned, there are danger accidents are happening frequently due to the gap between the train and the platform and the line crossing. So in this, by proposing or implementing this type of solution, we definitely improve the passenger safety, and it's effective and practical, and it saves hundreds of people yearly. So these are some references. that we had referred. For this time being, this is all about my project. So if I will be happy to give answer of any question if you have. Thank you.
Shreya,
Yes, ma'am.
tell me one thing. Why do you think the government has not yet implemented? As in, obviously, some security mechanism or something, some loophole must be there, no? Due to which the government has not yet implemented these security gates and everything which you have given in your presentation.
Ma'am, can you repeat this question again?
I'm trying to say that the solution that you are giving is that the security gates need to be put, the sliding gates need to be put so that the person won't fall down. Why do you think the government has not yet identified this loophole?
Because government needs to there are many frequently accidents that happen, but governments I don't know really why they ignore that type of system, because it's this system is required some time to implement it.
From where did you get the idea? Did you refer to some papers where this idea was mentioned?
No, ma'am. I one thing I mentioned here, in first year we had EDP, that is Indian Exploration Design Thinking subject. In that we learn some basic of IoTs in technical, non-technical, and at that time teacher told us to design one project that solve the real world problem. Then we search on many different areas like agriculture, industrial, and transportation, and we realize in transportation system, as I shown in this previous slides, that is many accidents, videos of accidents. So we analyze that type of accidents. Then we visited our railway stations like Takari railway stations and Shinori railway station. Then we discuss with station master and workers, and station master then we realize there is a huge problem like accidents, and government ignore that such type of problem. So we decide to take over to give some solution on that, and we discuss with our teachers and our team members, and we create this type of project.
Okay, thank you, Shreya.
Thank you so much, ma'am. Ma'am,
Thank you
can
so
I
much for the presentation.
leave now?
Yes, okay.
Thank you so much once again.
So, yeah, now we are moving forward to the next presenter, and we have R. Usha Rani with the paper title Cognitive Methods for Solution to Multicollinearity and Feature Selection in Regression Analysis for Thyroid Disease. And ma'am, are you there? I believe we do not have her in the session. So moving further to the next one. And now we have Abhijit M. to present his paper on the title Cryptocurrency Pre and Post COVID-19, a Time Series Analysis. Sir, are you there in the session? Well, I see him in the list. Is there any issue with the audio? Abhijit sir, are you there in the session? So for now, we have Deepak Sharma to present his paper with the title Driving Towards Tomorrow, a comparative study of electronic toll collection and satellite-based tolling in India's vision on Viksit Bharat 2047. Sir,
Yes.
you may start with your presentation now.
Ma'am, give me share, right? Okay, thank you.
Yeah.
Okay, my screen is visible. Hello.
Yes, sir. Now it's visible.
Okay, good afternoon, dear all. My paper ID is 2218, and my title of my research article is Driving Towards Tomorrow, a comparative study of electronic toll collection and satellite-based tolling in India's vision on Vikasit Bharat 2047. So, in this paper, these are the contents: introduction, history, objective, satellite-based tolling, how it's work, key features of toll checker include then vehicle to roadside communication, comparative analysis between electronic toll collection, etc., and new satellite-based toll collection system. Then conclusion and references. So, what exactly our system is working on with the help of like everybody knows that vehicle utilizing toll highways, HOV lanes, toll bridges, and toll tunnels can have their toll fees automatically collected via a wireless system called electronic toll collection or ETC. We can say that. So these vehicle with automated radio transponder devices pass through roadside toll reader devices in ETC system. These devices triggered the transponder which transmit back and identifying members, registering the vehicles use the road and electronic payment system charge the user the toll. So actually, this is the history. William
Deepak, please run the presentation. The presentation is not visible. I can just see the first screen.
Okay. Now it's visible, ma'am?
Yes.
Okay. Okay. So this is the history. William Vickery proposal 1959 introduced electronic tolling with transponder and central billing for the Washington metropolitan area. Singapore's innovation, it is on 1947. Italy's Telepass 1989. Norway, Portugal 1990s. Japan ETC 2.0, that is 2018. So we can use this system using our scanner. So these are the objective of my research article: to assess the technological feasibility and compatibility of ETC and satellite-based tolling system with India's in vision transportation landscape by 2047, to compare the contrast and operational efficiency, transaction processing speeds, congestion management capability, users experience associated with ETC and satellite-based tolling mechanism, to evaluate the economic viability, cost effectiveness, revenue generation potential, and long-term financial sustainability of deploying etc. and satellite-based ETC and satellite-based tolling infrastructure in alignment with India's developmental objective for 2047. Last but not the least, to examine the policy implication, regulatory frameworks, institutional arrangement, and legal consideration relevant to implementation and integration of ETC and satellite-based tolling system, ensure and compliance and governance alignment with Vikasit Bharat 2047. So actually, this is the satellite-based tolling concept, how it's work. So this is the overhead cameras. We call as video tolling system is there. Video tolling as depicted this figure utilize overheads camera for vehicle identification, employing license plate identification recognition technology. When a vehicle passes beneath a camera situated on overheads, gantries capture and images of its license plate Subsequently, optical character recognition, that is OCR software, deciphers the plate image, extracting alphanumeric characters. This information is then cross-checked against a database to ascertain the vehicle's owner. In case where vehicle lack toll accounts, video tolling is often combined with alternative method to ensure the payment are enforced. So these are the key features of the toll checker includes, that is, one gantry solution is there, wet calculation, that is Excel count and relay detection, support cutting edge enforcement measure, including online booking and communication. Next one is complete adherence of road tolling ORT regulation and absence of visible light even at night are example of safety elements. Capability to recognize license plates from the across the world, smooth interaction between DSRC and GPS system. So this is the vehicle to roadside communication we have discussed in this presentation. So actually, what exactly these transponders are becoming the most widely used method of vehicle identification in tolling system today. This technology involves the insertion of radio frequency, that is RFID chip into a device or a label, and is referred to an electronic tag. Usually, the electronic tag is attached with this windshield next to cars rear view mirror. Then these tag reacts to a radio signal sent out the transmitter when the vehicle passes under a gantry that mounted transmitter as per the figure. Although experiments have been conducted with a lesser and infrared signals, the radio frequency spectrum provides the highest precision. So this figure shows that the entire activity of vehicle to roadside communication. These are the algorithm which we have to frame, first stage is initialization, then vehicle position determination, satellite communication is there, data transmission. Then after that, data queries concept is going on. Then toll calculation is very important thing. Transaction authorization, then confirmation signals is there, payment deduction, transaction logging, and exception handling, and end of the transaction. So these are the some comparative analysis between electronic toll collection ETC system and a new satellite-based toll collection system. So we have focused, first of all, technology. This is the RFID DSRC and ANPR GPS system. Now it is easily converted into satellite communication only. Infrastructure requirement. So here in our existing system, dedicated toll booths, gantries, RFID readers, roadside equipment, etc. Here, minimal physical infrastructure relies on satellite communication. So vehicle identification method also sometimes very lengthy RFID tags. If it is not scanned, then we can wait for 10 to 15 minutes. Then transponders, license plate recognition, here satellite positioning data we can use in new satellite-based toll collection system. Coverage areas, the existing system is very limited, and these new satellite-based toll system nationwide coverage is there. Accuracy here.
There is some network problem from his side. So Deepak, we cannot hear you. Your audio is mute.
Okay, so actually this is the conclusion. The satellite based tolling system uses onboard units, that is OBUs, and global navigation satellite system, that is GNS, for precise vehicle positioning, transmitting data to ground control station for toll calculation based on predetermined criteria. This ensure accurate and fair tolling system is available with a transaction authorized mechanism, enhancing system integrity, automated payment deductions are there, and detailed transaction logging streamline processes, revaluation is toll collection. These advanced system significantly improves transportation infrastructure management and user experience, aligning with India's vision of Vikasit Bharat 2047. So these are the references which I have used for my research article preparation, prepare for research article. Thank you. Actually, our Minister Nitin Gadkari, Honorable Minister Nitin Gadkari also means taking this concept, and maybe within 2 or 3 years, it will be implemented in India also. So thanks a lot. Thank you.
Thank you for the presentation, sir. Ma'am Priyanka, would you like to ask one question?
No, Anisha, you can move on to the next presentation.
Okay, ma'am. Thank you, sir, Deepak, for the presentation.
Thank you, ma'am.
Okay, so now we have R. Usha Rani with us with the paper title Cognitive Methods for Solution to Multi-Collinearity and Feature Selection in Regression Analysis for Thyroid Diseases. Ma'am, you can share your screen and start the presentation.
Yes.
Is it visible, ma'am?
Yes, it's visible.
Okay, thank you, ma'am. So my research title is The Cognitive Methods for Solution to Multicollinearity and Selecting Features in Regression Analysis on Thyroid Disease. Here, regression analysis, the roadmap of overview of our presentation is first introduction and the literature review, research gap, problem statement, research objectives, conclusion, and references. Here, the problem definition and the why we are selecting this regression analysis with multicollinearity means most of the past research has been done using regression analysis without concentrating the multicollinearity problem. The multicollinearity problem is nothing but the variables that are used in data set, independent variable and a dependent variable, both strongly correlated to each other. It will creating an overfitting problem. This will create an issue for every predictive analysis or classification problem. So to avoid the overfitting and multicollinearity problem, by use of several techniques are possible. Some of the techniques are ridge regression, lasso, elastic net, and the principal component analysis. In this research, I am using this. We are using ridge estimator, principal component analysis, and lasso regression. There is a difference between them. I would like to tell what are all the differences and compare one with another, and where we can utilize these techniques in several data sets at the same time. So most of the past research using a variation inflation factor in ridge regression, that is this VIF factor indicate greater than 5, then the researchers eliminate the slowly or not strongly uncorrelated variable or slightly correlated variables are removed from the data set, and the rank other features and utilize the most toppest ranking features in their research. But it is not the way forever. For example, in my past research, we are using PIMA Indian dataset for diabetes patients. Here, the skin thickness is one of the variable. It will create overfitting problems. So most of the researchers eliminating this variable from the dataset. But if I concentrate any diabetes complications like neuropathy, nerve disorder, and kidney disease like that, the wound or skin thickness is a major parameter. So we need to keep the variable without eliminating the dataset, even if it will uh, slightly correlated to the dataset. Then how to do that? Avoid at the same time we need to avoid the multicollinearity problem. So these are all the literature survey related to that. Most of them using principal component analysis, LASO and other things, but not concentrate on the multicollinearity problem. So here research gap identified by the Lacuna is problem of overfitting resolved by using this research, and tiresome feature elimination from the dataset and need of multicollinearity diagnosis on healthcare data in thyroid disease. So this research focus to investigate the thyroid disease risk factors and analyze how it lead to severity to the patients from functional and test factors through machine learning techniques with predictive analysis. And when a regression model tests two significantly associated variables, that is the problem of overfitting occurs, how to resolve using these RIDGE, PCA and LASO. So this is the research objectives to resolve multicollinearity problem using RIDGE estimator and the principal component analysis and LASO regression. To compare these various machine learning prediction algorithm performance in thyroid complication, and the results summarized here. Here the architecture diagram of the proposed work is, first we load the thyroid disease dataset. After that we need to split training, split and test dataset. Then we train the model using RIDGE, LASO and PCA to analyze the results and compare one with each other. So after that, to identify the parameters, which one is leading topest ranking for thyroid, contributing to lead the thyroid disease, then which one is slightly correlated variable, first we need to identify using these machine learning algorithms. After that, to recognize a multicollinearity problem is occurred or not. So here the phenomena is when two or more predictors are correlated. If this happens, it cause unreliable results for prediction analysis or either classifications. So to resolve this by using this. So how to resolve this means, what is the difference between PCA and other LASO techniques means principal component analysis is the best for dimensionality reduction method. Here we can choose which one is the topest ranking features and which one is the slightly correlated variables we can eliminate from the data set is possible using information gain and other parameters when we embed with the principal component analysis. But which is best suitable for dimensionality reduction only, but not suitable for feature selection, because we need additional embedded techniques, information gained like that. And when we compare it with LASO regression, the least shrinkage absolute lambda technique, we can use it. L1 and L2 normalization, we can do it with RIDGE and LASO is possible. But the difference between RIDGE and LASO is, LASO, it can shrink the coefficient of the parameters towards 0. So what are all the slightly correlated variables available in our data set, which is transformed into 0. So slightly correlated variables removed from the data set, and to avoid the multicollinearity problem by LASO is possible. This is the advantage of LASO technique. But when we concentrate on RIDGE estimator, it is also one of the minimizing the cost function by using L2 normalization is possible. But the difference between LASO and RIDGE is, RIDGE, it does not shrink the parameter entirely 0. It can shrink the parameter towards 0 only. Nearby 0, we can get some value. So we no need to eliminate this parameter from our data set. For example, the slightly correlated variable, skin thickness in diabetes dataset or thyroid dataset, any features are available here, then which are not, no need to eliminate from the dataset, because in future it may be create some problem. It may be useful for our research. Therefore, we need to maintain the dataset, but we need to reduce the dimension. So reduce the dimension means, suppose if we are drawing the square matrix, then the background may be dotted line or dashed line. The solid line indicates the strong feature. Similarly, the strong features we need to keep up with our data set. At the same time, we no need to eliminate the slightly correlated variable. We need to keep the variable in future analysis. At the same time, we avoid the overfitting problem. The ridge can also done successfully is possible. These are all the differences between PCA, LASO, and the ridge regression. So after implementing this, we can.
I think there is some network problem from her side.
Is it clear, ma'am, now?
Yes, it's visible.
Thank you, ma'am. So all accuracy and other evaluation parameters done using this confusion matrix. Next, the graph representing how to identify the best lambda using ridge regression on thyroid disease. Here the triggering threshold point from past research work. Here the indicating it will give string value nearby 0, not in 0. So we can get the best lambda from using ridge regression. Similarly, we can use LASO model in thyroid data set. Here also nearby the value, we can get it from that. And when we compare with one another, it will give a ridge gives us better results compared to all other results. And similarly, the multicollinearity resolving using ridge estimator and LASO comparison, that is figure 5 indicated. Here also ridge and LASO contributing more than PCA. So all the features are ranked through all this ridge and LASO, everything is possible. Then we can categorize all those variables and we can fed into our machine learning model. We choose which one is the strongest and which one is we need to eliminate from the data set or keep the data set without overfitting. All we can decide using this these machine learning techniques, ridge, LASO, and PCA are possible, depends upon our problem. So from this, we can conclude thyroid is most serious and expensive complication because it causes disability in every important part of the human body and it lowering the quality of life. So only early detection allows it to be partly handled and eliminated. At the same time, when we fed any data set into the machine learning model, we need to identify any that multicollinearity or overfitting, underfitting occurring in the model, it will gives us the wrong results. So we avoid the wrong results using these techniques, PCA, ridge, LASO, depends upon the problem, we can choose it. If we want to remove slightly correlated variable, we can use LASO regressions are possible. If we want to keep the variable but avoid overfitting, we can use ridge model is possible. Only we want to do dimensionality reduction, then we can choose PCA. Dimensionality reduction along with PCA, if we want to do, we can adapt with information gain along with PCA are possible. These are all the conclusion about this research. Thank you, ma'am. Any queries?
Ma'am, why did you choose thyroid only?
Because several the past research using only diabetes like that, but only 8 or 9 features available. We can't compare one with another ridge PCLA, so like that. So here we have so many features also. Then how to select and how to rank the features one another, which is possible when we use more features healthcare dataset, not only thyroid. Here I am choosing thyroid dataset. We can choose any of the dataset which will helpful to avoid multicollinearity, not only in the healthcare sector.
Okay. Thank you.
Thank you. Thank you.
Thank you for the presentation, ma'am. Just one question. Can you please confirm your name? As
Sure.
here in our list, we have the name of R. Usha Rani, but in Zoom, your name says Dr. Saranya. So,
We both authors of this paper, ma'am. I am the first author of this paper.
so you're R. Usha Rani, right?
Dr. R. Usha.
Okay. Okay. Thank you, ma'am. Yeah.
Thank you very much.
Okay. So moving on for the next presentation, we have Abhijit M with the paper title Cryptocurrency Pre and Post COVID-19, a Time Series Analysis. Sir, you may start with your presentation now.
Thank you, ma'am. Thank you, ma'am. Am I audible, ma'am?
Yes, sir, you're audible.
Thank you. second. So, good afternoon, everyone. I'm really glad to be in this conference, first of all. So, my name is Abhijit. I'm an MBA graduate from Amardas Global Business Kochi, and I'm here to present my research on the intriguing and rapidly evolving world of cryptocurrency, specifically focusing on the time series analysis of cryptocurrency trend pre and post COVID. So our title is Cryptocurrency Pre and Post COVID-19, a time series analysis. So cryptocurrency is a digital or virtual form of a currency that relies on cryptographic techniques for security and operates on decentralized system called blockchain. Cryptocurrencies offers various applications, including serving as medium of exchange, a store of value, and a platform for decentralized application and smart contracts. Analyzing cryptocurrency using time series analysis provides insights into the adaptability and response of digital assets to pandemic-induced economic shifts, as well as comprehensive understanding of the market dynamics across various stages of global crisis. So our objective was to conduct a thorough analysis of cryptocurrency utilizing the time series and to investigate the market behavior pre and post COVID of the same. Our motivation of the study was to understand how pandemic impacted the market dynamics, in which in turn helps in understanding the changes in trading volume, price volatility, and investors' behavior. So the methodology, the data we used was a secondary data. The tools we used for this study was IRIMA Hall method, ACF and ADF. The interval we used for pre-COVID was 1st January 2019 to 31st March 2020. And for time period for post-COVID was 1st January 2021 to 31st March 2022. The frequency of the data is daily. It's a daily frequency. So the result and analysis, plotting and ACF were employed, and the results led to Holt and ARIMA models. In ARIMA models, 3 models were tested and outcomes were contrasted. The Holt model was compared with the model that had the least amount of inaccuracy. These were the plots and the results. First one, we can see 3 models, and the with the black color one was the least with the accuracy. So we took that and compare with the Holt model. We done with Bitcoin and Ethereum. So the conclusion was ARIMA was identified as the most effective model for analyzing cryptocurrency trends. The pandemic value increase. Despite the economic shutdown in 2020, the Bitcoin increased in value, starting at $6,965.72 and peaking over $29,000 in December 2020. In post-2020 decline, Bitcoin experienced a significant drop after November 2021, losing more than half of its value due to the global price declines and rising interest rates. Continued appeal despite obstacles and price oscillations, cryptocurrency continued to captivate investors and transform the global financial landscape. Thank you. Hello.
Yes, sir. Thank you for the presentation. Ma'am Priyanka, would you like to ask any question?
No, Anisha, move on to the next presentation.
Okay.
Thank you, ma'am.
Okay, so moving on to the next presentation. And we have Linda Wagisi to present her paper on the title, Guarding Inboxes, an NLP-based approach for email spam detection. Ma'am, are you there?
Good afternoon. Am I audible?
Yes. Yes, ma'am, you're audible. And you can proceed with the presentation
I'll
now.
share the slide. I'll share the
Sure.
slide.
Sure.
Okay. Is it visible?
Yes, it's visible.
I'll start. A
Sure,
very good
ma'am.
A very good afternoon to one and all. My name is Linda Varghese. I'm a faculty of MAHE, Manipal Academy of Higher Education. My paper ID is 166. The title of my paper is Guarding Inboxes and an NLP-based approach for email spam detection. The authors are Dr. Rajesh R. Pai, Dr. Nandini Kumari, Dr. Sapta, and Dr. Girish S. Moving to the present. Moving to the presentation outline, here the outline of the presentation is given, abstract. Next comes the introduction, moving to the literature review, methodology, results, conclusion, and references. Moving to the abstract, the unsolicited and misleading email material is sent in bulk to many recipients. Sometimes it is called as spam or junk mail. In the recent time, the increasing volume of such emails has created a lot of challenges to the electronic communication. My study tries to build a reliable and accurate method to detect and categorize email spam in order to improve the user experience and increase the information security. The study analyzes the text of the email using natural language processing and uses machine learning techniques to the original unbalanced and rebalanced balanced data set. Moving to the introduction, the email serves as one of the most used means of electronic communication. Due to its widespread usage, the email has turned into a means of dissemination for unseen and frequently harmful messages. The email spam exposes the recipients to potential risk related to security attacks involving phishing and fraudulent transaction, all of which present a serious problem to the users. As a result, an effective and precise email spam detection has emerged as a crucial issue for consumers as well as business. So advanced and flexible, also the intelligent spam detection algorithms are very much essential as spammers use increasingly sophisticated strategies in order to conceal their communication. Here we are using natural language processing techniques as well as machine language techniques in order to enable pattern recognition, extract features, and reliably classify the emails which is correct, that is spam or ham. So in my study, this study provides a comprehensive investigation of NLP and ML approaches for email spam detection. These are the literature review. According to so many authors have worked on this area and they have used different machine learning NLP techniques and even deep learning techniques also in order to detect the spam. Here various authors has worked on this particular area. So moving to my objective, the goal of my study is to compare the effectiveness of NLP and machine language techniques for email spam detection and also to identify the most accurate model. The study also analyzes the text of the email and tests various classification models with the help of both balanced and unbalanced data sets in order to detect and categorize email spam and also perform a comparative study. So here is the methodology that we have followed in our study is given here. So the first step is collection of data set. So the data set has been collected and it has two columns basically. The first column is category, which contains the information whether the text is spam or ham. The other column is the message. So the original data set has 5,572 rows. In that original data set, 747 tuples are spam messages and remaining 4,825 tuples are ham messages. So this data set actually it is unbalanced. Therefore, I have done the resampling and we have got a new data set. It consists of 748 spam tuples and 915 ham messages. So both the data sets are pre-processed and analyzed using different classification algorithms and compared the results. So finally, the models are compared using balanced and unbalanced data sets and accurate model is identified. So for that, first step what we have done is pre-processing of the email. So a series of pre-processing steps has been done. So the first pre-processing step what we have done is the text has been tokenized and non-alphabetic characters has been eliminated. Moving to the next step is lower casing. All the characters the case has been changed to lowercase. Then we have done the stop word elimination in the next stage. After that, we have done the stemming process, and it is used to remove prefix and suffix and get an underlying word. Therefore, thereafter, these words are joined back to the string, which is considered as the pre-processed data. The further we have gone to the feature extraction step. In the feature extraction process, useful features that can help with the categorization are taken from the pre-processed data. The pre-processed data in the study are subjected to TF-IDF feature extraction algorithm, and vectorization is also obtained as a result of it. Then afterwards, we have done the feature selection. What is the next step? That is done in order to enhance the performance of the model and minimize the noise. Also, important features are selected. So in this study, we have used select k-best algorithm method. So the next step is model building. So in the model building step, the total data set is divided into two subsets, that is training data set and test data set. For training, we have used 70% of data set, and for testing, we have used 30% of data. And next, we have used different classification algorithms like naive-Bayes technique, support vector machine technique, decision tree, and random forest methods. So after that, the performance, each classifier's performance in balanced as well as balanced and unbalanced data set is checked using performance metrics such as precision, accuracy, recall, and F1 score. The classification model all this classification model has got some accuracy, precision, as well as recall, plus this F1 score. So according to the result for the unbalanced data set, we have got 94%, 97% and 98% for naive-Bayes, decision tree, and support vector machine respectively. And for the unbalanced data set, 96%, 92% and 96% for naive-Bayes, decision tree, and SVM techniques respectively. So as per the result table, we can see that random forest outperforms with the highest accuracy and F1 score, that is 98% and 93% respectively in unbalanced, and 97 and 96% respectively in balanced data set. So moving to the conclusion, the proposed classification model has distinguished spam mails and ham mails with a notable accuracy using different machine learning algorithms like decision tree, naive-Bayes, random forest, and support vector machine techniques. And these models were tested with the help of balanced and unbalanced data set. As a future scope, we can say that this machine learning algorithms can be used for various other applications also, and we will be able to study the accuracy as well as compare the accuracy also. So these are the references that has been used for this study. Thank you, madam. Hello, am I audible?
Yes, ma'am. Thank you for the presentation. Ma'am Priyanka, do you have any questions? I guess she doesn't have any questions. Okay, so thank you so much, Linda. And moving on to the next presentation.
Shall I leave, madam? Because I got class now.
Yes, ma'am, you can stop sharing your screen.
Okay, thank you.
Okay, so next up we have Nishi with the paper title Pothole Detection Using YOLO V8. Ma'am, are you there?
Yes, ma'am.
Okay. Ma'am, you can share your screen and start the presentation.
Hello, ma'am. Good afternoon, everyone. I'm Nishi. I'm studying in KLE Technology University, known as DVB. My problem statement today is about pothole detection using YOLO V8, and the guide for our project was Virupaksha sir. My team members are Abdul, Amog, and Rohit. Talking about YOLO V8, it is a cutting-edge solution for real-time object detection. It emerges as an innovative choice, distinguished from the other approaches like YOLO V7 or YOLO V5. This state-of-the-art solution excels in achieving an optimal equilibrium between the speed and accuracy. The YOLO V8 comprises this through the implementation of an network architecture and groundbreaking anchor-free detection methodology. The utilization of YOLO V8 comprises accurate and rapid outcome, particularly in demanding scenarios. The indexes we have used in this projects are deep learning and then potholes, road safety, and YOLO algorithm for detection. Introduction of this is the advanced network architecture, anchor-free detection methodology, training approaches, and simplified decoupled head design of YOLO V8 strikes a balance between speed and accuracy. Stepping beyond the traditional applications of real-time object detection, YOLO V8 emerges as an innovative solution, directing its capabilities towards the targeted domain of pothole detection. In urban environment, potholes represent a persistent dangers, posing threats to road users and integrity of transportation infrastructure. This introduction explores the unique aspects of YOLO V8's role in pothole detection, shedding light on its customized network architecture, innovative precision strategies, and efficiency in urban infrastructure maintenance. We have used the key points such as specialized architecture for pinpointing accuracy in pothole detection, anchor-free pothole detection, strategies customizing for real-world pothole challenges, and decoupled head design, enhancing urban infrastructure efficiency. Objectives of this project are dataset acquisition. We have collected dataset from RoboFlow, and we have trained about 900 datasets. Then data pre-processing, develop and implement pre-processing techniques to ensure the integrity, quality, and consistency of the collected visual data, including noise reduction, normalization, and argumentation. Feature extraction, we utilize YOLO V8 object detection algorithm to extend meaningful features for the pre-processed visual data and enabling the identification of distinguished characteristics of potholes. Feature selections, we select features such as potholes for improving the efficiency of the model. Model training, we train the YOLO V8 model using the selected features to develop a robust system capable of accurately detecting potholes in various road conditions. Validation and optimization, conduct validation and optimizing process for fine-tuning of the model and enhances accuracy and real-time detection capabilities. YOLO V8 is a single pass detection than other models, which takes a layer by layer detection. YOLO V8 gives a single pass detection. It takes an entire image as an input and divides it into a grid of 13 into 13 or 12 into 12 cells, and it predicts the object whose center falls within the cell. This is an example. The literature survey, we have taken 4 literature surveys for our study. Pothole detection using machine learning and deep learning based on smart pothole detection with dilated convolution. Detection of potholes and cracks in asphalt pavement using UAV multispectral imagery. Corporative pothole detection and augmented reality rendering for enhanced situational awareness. Key features of YOLO V8 is acceleration, inference speed. So object detection in YOLO V8 achieves faster inference speed while maintaining a high speed of accuracy, surpassing other models. Versatile backbone. It offers and support for various backbone, including EfficientNet, RasNet, and Casper Darknet. It is flexible and allows the user to select the model suitable model for a specific application. Adaptive training to enhance overall model performance. YOLO V8 utilizes adaptive training techniques that optimize learning rates and balance the loss function during the training process. It advances data augmentation. It improves models' robustness and generalized capabilities. YOLO V8 leverages advanced data augmentation methods like mix-up and cut-mix. Customizable architecture. The architecture of YOLO V8 is highly customizable, allowing user to modify the model structure and give a specific requirements. Pre-trained models. We have taken pre-trained models for the YOLO V8 and making it convenient to use and enable transfer learning across diverse data sets. Model architecture. We undergo the sustainable architecture improvement of YOLO V8 and establish the state-of-art deep learning model for object detection. It enhances and has been aimed for performance, accuracy, and efficiency, and leading a significant advancement in computer vision. Methodology are data set acquisition, data pre-processing, feature extraction, feature selection, model training, validation and optimization, comprehensive analysis, development, and testing. These are the results we have found from our project. We have comprised all the images and made it into a video. And the video is like this. We have got an efficiency of overall 0.9%. And we have got the confusion matrix and F1 curve and precision recall curve as how our models is getting trained. How many potholes are there, how many drain holes are there, and how many screw holes. It differentiates all the images and gives us the output. The conclusion is the implementation of YOLO V8 for pothole detections is we have used the Ultralytics library and represents a significant advancement in automated infrastructure monitoring and safety, road safety. YOLO V8 successes in detecting pothole on not only streamlines maintenance effort, but also greatly contributes to the proactive measures for enhancing road safety. This technology of YOLO V8 and Ultralytics highlights the potential to play a vital role in tracking critical challenges in road maintenance and infrastructure monitoring. Thank you. Hello, ma'am. Am I audible?
Yes, you're audible. Thank you for the presentation. I guess ma'am doesn't have any question, so we'll be moving to the next one. Moving on, we have Aniket Bharadwaj with the paper title Predictive Analytics for Seismic Prone Region of the Indian Subcontinent Using Machine Learning Techniques. So Aniket, are you there?
Yeah, I'm here.
Okay. So you can start sharing your screen.
Sure. Yeah, you can. I'm not able to share the screen.
Just try out once again.
Yeah, sure. Just a minute. No, I'm unable to share. I'll just change my device. Maybe you can go ahead with the other person, and I'll present next.
Okay, no problem.
Yeah, sure.
So next we have Lakshmi A with the paper title Risks in Instant Loan Apps, Analyzing User Perception Using Machine Learning Approach. Ma'am Lakshmi, you can start sharing your screen.
Hello, am I audible?
Yes, you are audible.
Okay. Is the screen is visible?
Yes, it's visible.
Thank you, ma'am. So, good afternoon, everyone. So, today I am discussing my research on the basis of in the sector of instant loan application. That is, particularly, we are concentrating on the risk. We are analyzing the risk perception by reviewing the reviews that are given to through the online means on the Android Play Store and App Store. So instant loan apps that more popular nowadays. It's a essential part of the financial system nowadays, and also it providing instant access to the credit for individuals, and also they lacks to access to the traditional banking services, and the use of smartphones and also advancement in the digital finance. The use of this instant loan apps is more frequent nowadays, particularly at the time of COVID-19 pandemic. Uh, the user for this apps is increased very widely. But while this application provides considerable convenience and also financial supports to their customers, but there are also very risk is associated with that application. Concerns such as uh, predatory means uh, lending practices, and also the high interest rate they are providing, and the data privacy issues have emerged as a significant factors affecting for the user experience. So our goal of the study is to investigate the key factors that influence user perception of the risk in the instant loan apps, and also to investigate how these risks impact user trust and also the adoption of this application. and to highlight the need for the protection measures to safeguard the consumers, and also promote responsible lending practices. And also by analyzing the customer's review, we are using this machine learning techniques. This research aim is to offer a comprehensive understanding of the benefits and also the potential drawback of this instant loan app. Ultimately, we are providing the insight for providing user experience and also ensuring the responsible financial services. So here are the main literature review that we are focused on our research. So the first one is demystifying the mystery behind the loan apps in India. That is written when the researcher is Sarida M. So they are covering the problem with the loan apps in India, such as exploitation and suggestion precaution based on RBA guidelines. It is using a regression method. And the second one is how platform user power relationships algorithmic accountability. So this is by Ramesh D. Kesh Verma, V. Wang D, and Sambhavish Vishan N. And here it examines how Indian users, despite issues with the high fees and privacy, feels responsible for their circumstances rather than blaming the platform. So in this, they are using the data collection method. They are using primary data to collect the data. And are fintech lending apps harmful? Evidence from user experience in India market. So here they are also taking the real-time experience from the consumers, that they are actually giving the primary data for use for analyzing this research. And the next one is study of Twitter sentimental analysis using machine learning algorithm on Python. So our machine learning, we mainly focused on this paper to grab our research. So the main research questions are: how do user perceive and evaluate these instant loan apps? And the next one is: what are the main risks associated with the instant loan app? What factors contribute to the user decision making when decision making when the instant loan apps, how they are using, how what is the main feature for they are using the instant loan app? Developing a classification model for support vector machine and also naive basis. So here the methodology. So the research methodology is designed to thoroughly analyze the customer reviews of three particular Indian instant loan apps, utilizing a series of steps from data collection to advanced sentimental analysis. So this approach integrates various data processing techniques and machine learning model to cover the feedbacks by reviewing them. So our data collection is based on Android Play Store. So we collected around 8,998 reviews. These reviews are rated on the scale from 1 to 5, where 1 indicates very poor and 5 indicates excellent. So the first is pre-processing. So in the pre-processing, the data will be lowercasing. The all text will be converted into lowercase to ensure the uniformity. And the next will be digit and special character removal. And the next is stemming. The words will be reduced to their root form to standardize the variations. Then stop word removals, common but insufficient words were removed to enhance the focus on meaningful terms. Then feature extraction. So in the feature extraction were performed as this technique will convert textual data into numerous vectors by evaluating the importance of each term in relation to the entire data set. That is, it will highlighting the relevant word based on the frequency, and also it will help to capture the conceptual, contextual things. And also mainly we are focusing on the machine learning model, that is one is naive basis and the support vector machine. So we are using this machine learning to get the sentimental analysis. So we are using the Python natural toolkit. Naive basis, uh, it is a classifier uses by Bayes' theorem to predict the sentiment of the text basis on frequency and probability of word being positive or negative. And it classifies reviews into binary category and also in positive and also in negative based on the probability. In support vector machine, it aims to the find of the optimal hyperplane that separate positive and negative sentiments in feature space. And also it actually maps the data into high dimensional space to distinguish the sentiment classes effectively. And also we did a word cloud. Sorry. Word cloud. So the word cloud is we actually visualize the reviews using the NLTK tool pack. Word cloud provide a graphical representation where the larger font sizes indicates more frequently occurring terms, offer a clear visual summary of common themes and sentiment expressed in this review. So these are the findings. So after collected these reviews, we performed the naive basis model and also support vector machine. So the naive basis model performed well in classifying the sentiments in the customer review of instant loan apps, that it actually successfully reviews the performance showed as a sentiments, that the result indicates the it is a good starting point due to the simplicity and efficiency. So we can begin the analysis by using this naive basis because it is a simple method and also it's a simple method and also its efficiency, but it will not always capture the full complexity of the user sentiments. So actually we did a comparison between this naive basis and also the support vector machine. And in the case of support vector machine, it distinguishes the difference between the sentiment classes and with the higher frequency compared to naive basis model. This suggests the SVM is better suited for handling the complex patterns and also the relationship between the sentiment data. Also provides a perceived understanding of user feedbacks through our study. And the comparison is that SVM and naive basis model are outperformed in terms of accuracy is by the SVM, because the SVM compatibility to manage the relationship in the data makes it efficient for analyzing the customer perception in the instant loan apps. But while compared to this naive basis, it provides a less simpler approach compared to this SVM, and offers a better performance for our specific need like understanding the sentiments in the customer review. So the next is the word cloud. So this is a positive word cloud that we got from our review. So user choose to use the instant loan apps for various reasons. So they will give their review as what they are experienced with that app. So the word cloud highlights the perceived ease of access, that gatekeeper, and also speedily approved time, that check time, which have an impact. However, deeper factors including the requirement and limitation access to the standard financial product due to loan credit rating, and lack of document. So a lack of financial knowledge might leave people vulnerable to use the app is. And in the case of negative word cloud, it shows that it shows the key danger taken suitable for debt, that is unclear risk verification, simply involvement of unverified lenders, posing security risk. Our suggested pressure techniques, perhaps forcing customers into a decision without thorough review of loan terms. Then services may be regarding into the perceive of ease of obtaining loan, and also possible concern with the customer service. So in the conclusion, our study explores the fast lending apps using machine learning approach to understand the perception and also associated risk. So these apps are crucial in India, that they are very famous in India, that providing financial supports to those with limited access to the traditional banking. Like college students, and also financially the maybe the freshers who are appearing for the new jobs, they are having, maybe they are having a limited source of money, so they will use these types of apps for their financial uh, f- um, uh, financial means things for the help of through the finance. And despite these convenience, they pose challenges such as high rate interest, predatory, the lending, and the data privacy concern. Through our analysis, night basis and the sentimental analysis, also from the word cloud, identify the common theme and attitude towards this app. Finding highlights the need for financial literacy, transparency, and also ethical practices. So future researchers can also focus on developing a balanced regulatory framework, and also after exploring this user experience, and also ensuring algorithmic accountability. These research offers a valuable insight for users and providers, and promoting informed decision making, ethical lending, and also improve regularity oversight. So this, by analyzing this users this re, the by analyzing the review, the customers is having a 60% positive towards this apps, but there are so many limitations to this app. When regularity will make any kind of regulations towards this app, it may be helpful for them who are using regularly for their day-to-day activities. Thank you.
Thank you for the presentation, Ma'am Lakshmi. Ma'am Priyanka, do you have any questions? I guess he doesn't have any questions. So thank you so much. And now we'll be moving on with the next one. So we have Aniket Bhardwaj. Sir, are you ready with your presentation?
Yes, I'm ready.
Okay. So you can start presenting your screen.
Yeah, sure. Is the screen visible?
Yes, it's visible.
Good morning, everyone. Thank you for being here today. My name is Aniket Bhardwaj, and I'll be presenting a research paper on predictive analysis on sea-string-prone regions in India using machine learning. The co-authors are Dr. Ruchi Sharma, Dr. V.K. Chandana, Dr. Manju Vyas, and Nidhi Tiwari. Yeah. This is the table of content of my paper. We'll cover in this presentation, we'll cover introduction, dataset overview, methodology, algorithms used, results, conclusion, and references. Introduction. We will talk about the background first. So imagine a world where you could predict the earthquakes more accurately. Just think about the lives that can be saved, the properties that can be preserved, the communities protected. That's our goal. Earthquake which exceeds over 2.5, they can be felt, and any of those which are over 4.5, they can cause significant damage. And the timely predictions of those, that can be a game changer. However, predicting earthquake isn't that straightforward. It requires high quality diverse data, which is often hard to obtain. The traditional forecasting methods, they frequently lack precision and often fail to provide a timely and accurate prediction. This is where ML comes in play. While ML holds great promises, when they are combined with the domain expertise, they truly become effective. Our objective is pretty simple. We aim to improve the prediction of earthquake magnitudes and epicenter in India. We aim to achieve this by leveraging advanced techniques such as machine learning, mathematical analysis, meta heuristics, and AI models. Ultimately, we want to enhance the prediction accuracy and deepen our understanding of seismic events. Dataset description. So going for the dataset overview, we collected it from data.gov and Kaggle, where we got a dataset of all the recent up to 2015 seismic events in and around India, the neighboring countries included. The key parameters which the dataset had was latitude, longitude, depth, magnitude, time and location of the event. The information also included seismic activities and historical occurrences. The key parameters, the features which we included in our ML training were latitude, longitude, depth, and the target magnitude. The pre-processing, since most of the data was linear, the pre-processing steps only included handling the missing values and cleaning the data to ensure data consistency. And this is the heat map of the data which we had. Moving on to the methodology which we followed. The methodology was quite simple. We went for data acquisition, where we collected seismic event parameters from various sources, and ultimately we gathered latitude, longitude, depth, magnitude, as I stated before. The pre-processing step, we handled missing values and cleaned the data. Feature selection, out of all the data which were there, we selected numerical data, latitude, longitude, depth, and targeting magnitude. When it came to model selection, we chose over 9 different algorithms, which were from linear to ensemble methods. Then we trained using all those 9 algorithms, hypertuned them using grid search and random search, and evaluated the model performance in a comparative manner. After that, once the model was trained and we achieved a good accuracy, we cross-validated it using different data which was not included in the data set, and then we cross-validated its accuracy. These are the algorithms which we used. We used logistic regression, KNN, support vector, decision tree, random forest, gradient boosting, ADA boost, naive Bayes, and neural networks. You can see what are their pros and cons? As you can see, lossy regression is a baseline model. It is efficient. KNN, they captures local patterns. Support vectors, good for non-linear data. Decision tree provides interpretability. Random forest reduces overfitting, captures complex interactions. Gradient boosting, top performing model है हमारा, and it captures subtle patterns which were not being able to capture in other models. And ADA Boost focuses on misclassified instances, and naive base was scalable. It is suitable for larger data, but did not provide me with good predictions. And ultimately, neural network. Here is a table of the accuracies and the models we achieved. So here, the top performers were gradient boosting and random forest. Due to the data limitation, the accuracy is quite low. We got the maximum of 79.16 and another 79 percentage. In simple methods, generally they perform better with seismic predictions. This is the data simulation on Google Earth of the data we predicted after the training of the ML. And as you can see, it covers maximum of the North India, the part of Arunachal Pradesh, and the earthquake regions over China and all. So for a better accuracy, we utilize the data in and around the India because of even if, like, I remember one example, there was one earthquake which was more than 7 to 8, and it was somewhere 300 kilometers away from Arunachal Pradesh. The impact that affected, but the epicenter was in China. So we will be able to predict earthquakes in and around India. The conclusion, when it comes to the conclusion is quite simple, that we were able to figure out the effective models, which are gradient boosting and random forest. They emerge with the most accurate data. Data quality is something which is highly in demand. We need an high quality and significant data, which will improve the accuracy of the predictions also. Data has to be properly cleaned. Integration of the techniques. So now combining machine learning with domain expertise is something which will increase the predictivity capabilities of the ML model. When we go towards the future direction, we would like to improve the model performance by including more algorithms, improving our data set and processing techniques, extend its applications to more regions, and hold different contexts reliable to prediction. And ultimately, we would like to collaborate with the geologists or data scientists, where we hope that we'll be able to advance our model and attain a higher accuracy. When we go towards the impact is very simple. We'll be able to be prepared for the earthquake if the prediction is accurate, and the government can utilize this model to at least be one step ahead from those. Though we cannot avoid earthquakes, but we can be prepared for them. So we can improve our security measures and resource allocation accordingly to the predictions, and then we can make it a bit safer, a bit well planned to face the disaster. These are the references that supported my research. I would like to thank everyone for their attention, and I'll be happy to take any questions if you might have.
Thank you for the presentation, Sir Aniket. Ma'am Priyanka, would you like to ask any questions? Yes, she doesn't have any questions, so we'll be moving on with the next one.
Thank you so much.
Yeah. And now we have MD Parvati with the paper title Unravel the DFL Level Among Nationalized Bank Women Employees in Kerala. Ma'am Parvati, are you there? Ma'am Parvati, you are not audible to us. Ma'am, if you're facing any technical issue, okay, she has started the screen sharing.
Am I audible, ma'am?
Yes, now you're audible.
Okay, thank you so much. Okay, very good afternoon to all. 1 second. Okay, I think I am visible to all.
Yes.
Okay, thank you so much. Okay, very good afternoon to all. Myself, Dr. Parvati MD. I am working as a faculty associate in the Department of Commerce and Management, Amrita School of Arts, Humanities and Commerce, Amrita Vishwavidyapeetham, Amritapuri campus. And the topic of my research paper is Unravel the Digital Financial Literacy Level among Nationalized Bank Women Employees in Kerala. Okay. And the other co-authors are Dr. Diana Dasman, Vice Principal as well as Head of the Department of Commerce and Management, Amrita School of Arts, Humanities and Commerce, Amrita Vishwavidyapeetham, Amritapuri campus, and Dr. N. Kumar sir, Professor as well as Research Head, Amrita Vishwavidyapeetham, Kochi campus. So digital financial services, it's a capability to access and utilize financial services via digital platform at one's own convenience, and the rapid digitalization of these financial services brings revolutionary as well as innovative digital financial services. It improves financial inclusion, and India, we can also mirror it in India, where a diverse array of digital finance services also introduced. These digital financial services integrate the economy by introducing various revolutionary as well as innovative digital financial product and services, but it poses many challenges as well as risks to the users. So in this context, digital financial literacy, it's a fundamental necessity for the effective usage of digital finance services, and it's an important educational component. As well as inadequate digital financial literacy, it's a substantial hindrance to the logical and efficient utilization of digital finance services. The digital financial literacy, it's a combination of digital literacy and financial literacy. Simply, we can say that digital financial literacy means financially literate on digital platforms. Then the statement of the problem. So the widespread adoption of these digital technologies as well as abundant investment opportunities create significant challenges in making informed as well as effective investment decisions, as well as the complexity of investment products and the potential for misinformation and scams in the digital space increases day by day. So it's very essential to empower the individuals to achieve their financial goals, enhance financial stability, and promote overall economic growth. Then literature review. Some of the major studies were quoted here. Morgan et al. States that digital financial literacy is a prerequisite for the effective usage of digital financial services. And Lyons and Casana states that it's a combination of both financial literacy and digital literacy. And AFI, that's Alliance for Financial Inclusion, states that digital financial literacy, it's a multidimensional construct, and it's a combination of financial literacy, financial capability, and digital literacy. And Melinda Gates Foundation states that the digital financial literacy, it lies at a point where digital literacy and financial literacy intersect, and it enables the users to have full benefits of digital finance services. And T. Deviguma et al. Proved that the digital financial literacy of the adults varies based on education, and no other personal demographic characters influenced it. And the major dimensions that considered by T. Deviguma et al. Were the quality of digital finance services, the knowledge of digital finance service and digital financial service providers, awareness of digital financial risk and risk control, digital knowledge, practical application of knowledge and skill, digital savvy, self-determination to use the knowledge and skill, digital security awareness, positive financial attitude, gendered financial knowledge, rational financial behavior, and financial knowledge. And the research gap. No research was done to determine the digital financial literacy among public sector bank employees. And numerous studies shown that women generally have lower levels of financial literacy than males, regardless of the country. So the current study intended to determine the women's digital financial literacy level among those working in public sector banks in Kerala. And the research question is, how proficient are women employees in using digital financial tools and services? And the research objective is to unravel digital financial literacy level among the nationalized bank women in Kerala. And the hypothesis is, the null hypothesis is, the digital financial literacy among working women is not high, and the alternative is the digital financial literacy among working women is high. And the theoretical framework, the digital financial literacy, it's a concept that combines financial literacy, financial capability, and digital literacy. And AFI defines digital financial literacy as acquire knowledge, skill, confidence, and competencies to safely use digitally delivered financial product and services to make informed financial decision and act in one's best financial interest per individual's economic and social circumstance. And the Central Bank of Philippines defines digital literacy as competency in relation to financial literacy as financial literacy is a level of knowledge about financial concepts that are useful for a person to make financial decision, while digital literacy it's the ability of a consumer to use a variety of digital finance service with self-assurance and full trust in their benefits. Then research methodology. Here, exploratory research design were used for the study, and the source of data, primary as well as secondary data were considered, and stratified random sampling were adopted for the study. And the population is the total number of women employees working in the nationalized banks in Kerala. It's about 15,158, and the place of study is Kerala, and the sample size is 384 respondents, and it's computed as per Cochrane's formula of 1977. And the statistical tools were descriptive analysis, sum, and z-test. And then about the source of data collection. Here both primary as well as secondary data. And in the case of primary data, the responses were collected from the respondents through a structured questionnaire via direct survey and as well as through Google form. And the secondary data, the government reports from the state level bankers committee as well as information is acquired through filing RTI to the respective banks or to the RBI, and government regulations, academic journals, and additional online resources. Then about population. Here, population is the total number of nationalized bank women employees in Kerala, and it's about 15,158. This data is obtained from the report from state level bankers committee and by filing RTI to the respective banks. And as per the data, the State Bank of India comprises 6,790 women employees in Kerala, and Punjab National Bank 732, Bank of Baroda 946, Canara Bank 3,039, Union Bank of India 1,425, Bank of India 510, Indian Bank 505, Central Bank of India 340, Indian Overseas Bank 595, UCO Bank 195, Bank of Maharashtra 66, and Punjab and Sindh Bank 15. And sample size, here Cochrane's formula for finite population is considered for the study, and the minimum record sample as per the formula is about 376, and for the study purpose 384 responses were collected. Then sampling technique, the stratified random sampling technique were adopted for the study. Here the total population, that's 15,158 women employees in Kerala, were categorized into 12 stratas on the base of the bank in which they employed, and that's State Bank of India, Canara Bank, Union Bank of India, Bank of Baroda, etc. And here and after that, random sampling were adopted to select samples on the base of their population from each bank. That's about 172 from State Bank of India, 77 from Canara Bank, 36 from Union Bank of India, 24 from Bank of Baroda, 18 from Punjab National Bank, 15 from Indian Overseas Bank, 13 from Bank of India, 13 from Indian Bank, 8 from Central Bank of India, 5 from UCO Bank, 2 from Bank of Maharashtra, and 1 from Punjab and Sindh Bank. Total 384. Then here, some structured equation modeling is used to find out the determinants and their impact on digital financial literacy. And one sample z-test is used to evaluate the level of digital financial literacy among the nationalized bank women employees in Kerala. And here, both qualitative as well as quantitative data were used here. Sorry, the study comprises both qualitative as well as quantitative data. So, qualitative as well as quantitative techniques were used for the study. And this statistical analysis comprised 2 stages: descriptive statistics of the measured items, and the second stage, which is the proposed research model. And here, the data analysis, it comprises reliability, normality, the percentage profile of demographic variables, the digital financial literacy determinants and its impact on digital financial literacy, the level of digital financial literacy. First one, reliability. Here, Cronbach's alpha were used for the study, and all the constructs have reliability greater than 0.6. So we consider that data is reliable. And in the case of normality, Kolmogor's monotest is used to test the normality, and we can find that the data is normal. Then the percentage profile of demographic variables, it indicates that in the case of age, most of the respondents belongs to the age category of 25 to 45. In the case of education, most of them belongs to graduation. And in the case of income, most of them belongs to the slab group of 50,000 to 1 lakh. And in the case of marital status, most of them are married. And in the case of number of family members, most of the response have a family member of about 3 or 4. And in the case of number of respondents, most of them have a dependent of about 2. And about the determinants of digital financial literacy, here the major determinants or the major factors that consider for the studies. Okay, financial attitude, financial behavior, financial knowledge, knowledge of digital financial services, awareness of digital financial risk, digital finance risk control, knowledge of consumer right, product suitability, practical application of knowledge and skill, and self-determination to use the knowledge and skill. And the findings indicate that the digital financial literacy is equal to 0.343 of financial attitude plus 0.531 of financial behavior plus 0.192 of financial knowledge plus 0.743 of digital knowledge plus 0.696 of knowledge of digital financial service plus 0.664 of awareness of digital financial risk plus 0.750 of digital finance risk control plus 0.632 of knowledge of consumer right plus 0.705 of product suitability plus 0.826 of practical application of knowledge and skill and plus 0.631 of self-determination to use the knowledge and skill. Sorry. Okay, from this we can from the findings we can easily find out that that if financial attitude increases by 1 unit, the digital financial literacy increases by 0.343. Similarly, financial behavior increases by 1 unit, digital financial literacy increases by 0.531, and financial attitude increases by 1 unit, the digital financial literacy increases by 0.192, and if digital knowledge increases by 1 unit, digital financial literacy increases by 0.743. Okay, similarly, from this, we can find that the financial attitude as well as financial knowledge have a regression value less than 0.4. So we can conclude that these two factors are least significantly influence the digital financial literacy, while all other factors have significant contribution towards digital financial literacy. And among them, practical application of knowledge and skill is the most significant factor towards digital financial literacy. And here is a ranking of the determinants of digital financial literacy. Here, the practical application of knowledge and skill is the most significant factor towards digital financial literacy. After that, digital finance risk control, then digital knowledge, then product suitability, then knowledge of digital finance services, and after that, awareness of digital financial risk, then knowledge of consumer right, then self-determination to use the knowledge and skill, then financial behavior, then financial attitude, and the last one, financial knowledge. So this is the Sun model, which shows that all these determinants.
Sorry for interrupting you, ma'am.
Yes.
But can you please conclude the presentation now, as you have exceeded the
Okay, ma'am.
10
1
minutes.
second. I can hear. Yes, ma'am.
Yeah, I was saying, can you please conclude your presentation now, as you have exceeded the time limit for the presentation?
Okay. Okay, ma'am. 1 more minute.
Sorry?
1 more minute. I will conclude it.
Yeah, as soon as possible. Yeah.
Okay. So here we analyze the level of digital financial literacy among working women, and from the here one sample test is used for the study, and it indicates that here mean percentage score is here the mean percentage score is computed to find out the level of digital financial literacy. Here the mean percentage score is 82.46, and if the mean percentage score exceeds 75, we consider that it's high. As well as here the p-value is less than 0.05. So the analysis find out that, so we can conclude that the level of digital financial literacy among working women is high. But some factors such as financial attitude, the financial knowledge, and the knowledge of digital financial services, and self-determination to use the knowledge and skill, all these 4 factors have medium or good level of these factors among the working women employees in Kerala. So we can conclude that the digital financial literacy among working women is high, with improvements recorded in areas such as financial attitude, financial knowledge, knowledge of digital finance service, and self-determination to use the knowledge and skill. Okay, these are certain recommendations towards the government to improve digital financial literacy. And it's a conclusion that's empowering working women through targeted improvements in financial attitude, knowledge, digital finance service, and self-determination is essential for enhancing digital financial literacy and economic independence. That's all. Thank you.
Okay, thank you for your presentation, ma'am.
Okay. Shall I stop sharing?
Yes.
Or any question? Okay.
So with that, we have completed all our presentations for this session. And now I sincerely thank all our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough for you all. We, on behalf of the whole team, thank you for your support during this version and all the previous 8 versions of the conference, and we will be happy to have you in the 10th version in 2025. All the presenters would be
Anisha,
getting...
just to interrupt in between, I would
Yes,
like to
ma'am.
conclude by saying it was a wonderful session and all the participants, they gave wonderful presentation. So wish you all the very best for your future.
Thank you for your kind words, ma'am. Yeah. So further, all the papers have already forwarded to the Springer, and the publication will be live within the 6 months. So kindly cooperate with the team of ICT4SD 2024. And I would also like to thank our session chair for chairing this session. And here is a small token of appreciation on behalf of the team and Global Knowledge Research Foundation and partner. Thank you for your valuable presence, ma'am. And now I would request you all to please switch on your cameras for a quick snapshot of this virtual conference. Okay. Thank you so much, everyone. Thank you. Have a
Thank you,
nice day.
Anisha.